Last but not least, it's time for question 5, and we have some crazy charts going here. Okay. So we've got a big chart about certain car models, men and women, and the difference in price between the two, and the fact that women paid possibly more than they charged men. Okay, does the data provide convincing evidence that on average women pay more than men? Okay, so the idea behind this is, to me, notice that we only really have the difference here. So what we're doing is we're doing a statistical test. Now, what is the name of our test? We are doing a match pairs test for what we call the mean, the average difference in purchase price. So we're not just comparing men to women, we're comparing the difference between them, the mean, the average difference between the two. So what's our HO? Our HO is that the difference between men and women is, and we write it like this, the difference between the two is equal to 0. And we should also, whoops, let's maybe do it like this. Let's find it like this, is the mean price car for all women. And we'll do, it's going to be the mean purchase price of a car for all men. And we'll do the mean difference. And this is going to be the mean difference in purchase price I'll say where D equals, well, let's see the order here, women minus man. All right, so our HO is really just, we're talking about the difference here. So maybe I didn't need to do the whole UWUM thing. Our HO is always that we expect that the difference is 0. Now our HA, if it's women minus men and we think women pay more, then that would be greater than 0. W is greater than M, so a bigger minus a smaller will be a positive, a greater amount. That's what we're testing there. So we name the test, we have our hypotheses. Let's check our conditions. Let's see here. So let's do conditions. 1, do we have a random sample? Randomly obtained sample. The other condition we want to check is the normality of the sample. We can definitely assume that there's independence there. Okay, now when we look at 2, I'm going to say the distribution of price differences I'm going to say looks approximately symmetric without outliers. And 3, just for the fun of it, we can assume independence based on sample size. So there's always so much work in this question. Whenever they say, is there convincing statistical evidence? There's a lot of work that goes into it beforehand. So I'm actually going to forget about that. I just don't feel like that's good. Based on sample size. Okay, so we had random, and you can see here, I mean, again, if you were to put a line in the middle of where you think the middle is, it seems like there's about just as many below as there is above. There's like 2 high, 2 low. It seems approximately symmetric to me. So hopefully you agree when you see that. So up next, we named our test. We've stated our hypotheses. We've checked the conditions. It's time to actually do the test, and this will be a t-test. So I'll say, actually, above here, matched pairs t-test for mean difference in purchase price. The t-value itself is just going to be, well, the mean difference, which is 585, minus what we expected, which is 0, usually always, divided by, and this time since it's matched pairs, we have our standard deviation, divided by the sample size, which is 8. So be careful about that. We had 8 different vehicles. So super important thing to notice there. It's not just your typical standard deviation. There are 8 vehicles that make up that standard deviation. So be very, very careful about that. Okay, so let's calculate this thing. 585 minus 0 is just 585. We're dividing that by, I'll put it in parentheses, 530.71 divided by the square root of 8. And I get 3.12. So approximately 3.12. Okay, and now it's time to find the associated p-value, and we'll say is between, let's figure this out. We had a sample size of 8, so the degrees of freedom is 7. So degrees of freedom 7, and we're looking to where 3.12 is in between. It's in between 0.005 and 0.01. Awesome. So we got that. And you might want to say using t-table. Again, let's just do this. We're just doing a regular t-test. And so in other words, when it's a matched pairs, it technically falls under the category of a standard t-test. We have 585. Oops, sorry, the expected was 0. We have 585. Standard deviation is 530.71. We had 8, and we're trying to prove that it's greater than. So let's see this, calculate. Let's see, we get the 3.12, we get the p-value, which is in between 0.005 and 0.01. It's kind of smack dab in the middle. So there we go. And now let's conclude this thing. So how do you conclude? Since p-value is very small. Now we don't want to say that. We'll say less than standard alpha 0.05 or alpha equals 0.01. That's typically what you'll see. You'll have to see 0.1, 0.05, or 0.01. Since it's smaller than all of those, there is evidence we are rejecting. And what are we rejecting? We're rejecting HO, which means we're going with HA. Now what is HA? There is evidence that on average, women pay more than men in the county for the same car model. So one thing you might want to do is you might want to go back with the 5 minutes that we have left. Match pairs t-test for mean difference in purchase price of car models in the county between men and women. I'm going to go back and do that. Now this mean difference in purchase price, where D is women minus men. Hopefully that's obvious. Of car models for all in the given county. So just putting in a little more context. Okay, so let's see how we did. Question 5. So did we correctly compare the hypotheses test, which is that the difference is equal to 0 or that the difference is greater than 0? Yay, got that. Appropriate procedure is a paired t-test, so I said match pairs, right? And it was random. And again, we said it's normally distributed. And so the first condition's met because they were randomly selected. And 8 is not large, so the dot plot reveals a fairly symmetric distribution. So yay, mention that. All right, up next we got the 3.12. We did the exact calculation, nailed it. The degrees of freedom is 7. Okay, so the p-value is 0.008. Now we gave a range, that's okay. And correct conclusion in context. Because the p-value is very small, and see, look, they even use parentheses, so we reject. There is convincing evidence that women pay more in the county for the same car model. So I feel good about that, and hopefully you do too. Good luck.